The paper of the day is Dynamic Programming Strikes Back. Two highly efficient algorithms are known for optimally ordering joins while avoiding cross products. TDCCP, which is based on dynamic programming, and top-down partition search based on memoization. Both have two severe limitations. They handle only simple, that is binary join predicates and inner joins. However, real queries may contain complex join predicates involving more than two relations, an outer join as well as other non-inner joins. Taking the most efficient known join ordering algorithm, that is DPCCP, as a starting point, we first develop a new algorithm, that is DP-high, which is capable to handle complex join predicates efficiently. They do so by modeling the query graph as a variant of a hypergraph, then reason about its connected subgraphs. Then they present a technique to exploit this capability to efficiently handle the widest class of nonlinear joins dealt with so far. Their experimental results show that the reformulation of nonlinear joins as a complex predicates can improve optimization times by orders of magnitude compared to known algorithms dealing with the complex join predicates and non-inner joins. Once again, this gives dynamic programming a distinct advantage over current memoization techniques. Unfortunately, there are no experiments on join ordering for hypergraphs reported in the literature. Thus, they had to invent their own experiments. The general design principle of their hypergraphs used in the experiments is that they start with a simple graph and add one big hyperedge to it. Then they successively split the hyperedge into two smaller ones until they reach simple edges. The paper presented DP-hype, a join enumeration algorithm capable of handling hypergraphs and a much wider class of join operators than previous approaches. The extension to hypergraphs enables to optimize queries with non-inner joins much more efficiently than before, even for queries with binary join predicates. Now let's talk PS score for this paper. Overall, this paper is super hard to read and follow due to significant portion of the paper covered with maths and algorithms, so it gets 2 out of 10 on readability. With 14 pages long, it scores 4 out of 10 on length. It's a research prototype with hard to follow description, so that makes it 3 out of 10. Its industry value and learning meter is questionable, so it gets 3 out of 10 on each. Overall PS score is 3 out of 10.